Thank you and welcome, and thanks for inviting me, and nice to see so many people here in the nice location. So, I'm a professor in refrigeration technology. Originally, I'm from the Black Forest. In 1995, I went to Norway as a student and never returned. And now I'm here to tell you a little bit about why we have cooling in Norway. Norway has exported ice since the late 1980s, in 1880 around, and that ice was used to transport food, even to this region, so to keep the food refrigerated. Nowadays, why do we need cooling in Norway? Because we are producing a lot of salmon. You can see it from the number here. It's a very huge number when it comes to 66 billion SAR. That's our turnover in salmon or fish production and export globally. That's why we need cooling today, even in a cold country. But the journey until now on refrigerants has started, as I said, in the late 1880s, when Linde developed the ammonia refrigeration in Germany to make warehouses able to cool food and preserve the food, and some other fluids to brew other fluids all year long. The lobbying in 1930 and the introduction of synthetic refrigerants was starting a new era, which then lately was discovered in the 70s, and the Montreal Protocol came. We just heard about it. It was again a phase out of the chlorine stuff, but it was the lobby to do these HFCs, which we are now concerned. But it was the first initiative where we looked into natural working fluids, my colleague and Professor Gustav Lawrence, and he started this innovation. 10 years later, there was the Kyoto Protocol. It was focusing on global warming. F-gas regulation in Europe started 2006. It was revised now lately. And we have what Markus mentioned, the Kigali Amendment, which also this country has signed to. Again, we see a massive lobbying on now new fluids, which have a very short atmospheric lifetime, which is important, because that's the definition on GWP. This CO2 equivalent is related how much heat can be absorbed when that fluid is in the atmosphere. So if that fluid has a short lifetime, of course the value is very small. But is that smart? We will come back to that. The EU's F-gas directive is now updated, and now it's not a phase down, it's a phase out. In 2050, we are finished with F-gases in Europe in new systems. So what is the Montreal Protocol about? It's an amazing treaty. I mean, after 2 years, it was introduced, it was ratified by all the countries after 50 years of consumption of a fluid, which was a problem. It was Gustav, he invented a CO2 system to say, look, we could also look into another direction, not going further with synthetic refrigerants. We have, for example, CO2, and it was introduced for mobile air conditioning. So even the Mercedes cars have been tested in this country a few years back, and they have this kind of system in a Mercedes car, or in an ID, Volkswagen, or all the others also from Europe. They can do it. And hot water heat pumps, because of the exceptional properties of this fluid. So I will come back to that. The Kyoto Protocol was also the first international treaty on climate change, was successful, and you see some of the companies have changed their mind and even the products. But from that time, all these companies are launching and having only natural working fluids in these bottle coolers, for example. CO2 is back by that time, around 25 years ago. We see the first announcement of the CO2 water heater, which had an exceptional success in Japan. Now they have 10 million of these units, which were developed in our lab together with our Japanese friends. So now they do all this water heating with the heat pump instead of burning gas or oil in these dense areas, which had a lot of pollution. Now they can do it like this. So 10 million units. By that time also, the first car, fuel cell car, had a CO2 heat pump. It was successful. Now you can buy all the ID cars and all this with CO2 as an option, because it's also more energy efficient, and we will come back to that. Why can that be possible? How are we doing the challenging, or how did we do the challenging phase out of R22, which is still around in the world a lot. In the southern part of the world, the warmer parts of the world, we see a lot of R22. We see it also in the fishing fleets around the world still. Since 2010, we have no more R22 in Norway. Since 2015, even servicing is not permitted. So we are more finished with R22. Sorry. How did it happen? Why are we so concerned? No, people are not concerned, but you pay a deposit in Norway when you import a unit according to the GWP value. What does it mean? If you buy a system, look, if I buy a system now with 404A, the GWP is around 4,000. So 1 kilogram of that fluid, if it goes out, it represents 4 tons of CO2. And you pay a deposit, which is the 1405 kroner per kilogram times GWP. That means for 1 kilogram of 404A, you pay a deposit of 2,100 SAR. That's just the deposit. So if you, at end of life, bring that fluid back to the recovery system, you get the money back. If you have lost it, you have paid for the emission. That's how it works in Norway. And this is for all the fluids. The new F-gas regulation in Europe, as I mentioned, it has been updated from 2014. It was a kind of a phase down. Now they have decided to go for a phase out. And they even tightened the area which is just very near from now, very close. In 2030, look at the remaining possibilities. So they're very small. So a transition is even more urgent, or is very urgent in Europe, because even R32 has a challenge in that small range down there. So the next generation, how does the next generation of refrigerants look like? State of the art is the use of these F-gases, which we have done now for close to 100 years now, and the CFCs before and that time. It has a severe impact on human health. So it's not only the environment, it's also the health and, of course, the global environment. We have seen the depletion of the ozone layer, and it is not stopped. It has not stopped. It is still there. It's going back, but it's still a problem. Global warming is there, but now we see that we have also poisonous decomposition products of these short-life refrigerants, but also from other HFCs. And this leads to acidification of water and food. That is a problem. So that's the challenge. Are these really sustainable refrigerants? And where is the major source for this PFAS, which everybody's talking about? Look at the upper number. It's the fluorinated gases. And that's what we are typically using. So more than half of all the global PFAS is because of the refrigerant. And it gets even worse with the new refrigerant because they are really decomposing to 100% PFAS. So that's a challenge. And that's in your food, in your drinking water, in the mother milk. And there are many other severe issues with the taking up of vaccines for babies and all this stuff. So it's not healthy. And I can show you some solutions. If you measure this PFAS, you will find it. And even in GCC, there are a lot of PFAS if you just look at it. If you don't measure, you're not aware, you will not know. But have a look. Make an analysis of your drinking water or whatever you eat, you will find it. And it's just rising because, and especially in very dense populated areas, it's rising very fast. So why is Europe concerned about this PFAS? And countries proposed a restriction because this is, in a way, a challenge. People would say, well, it is because they have identified these governmental organizations. It was not a private initiative. It's the government. They have the responsibility for the people, and they have identified the risk on human health. And it is their duty. to take care of the people. And that's why these countries proposed a restriction. And what does it mean? Because it is a very high persistence of these fluids when they are released into the environment. They cannot be degraded by nature. That is the problem. So it's accumulating. It's just getting more and more. And it's just increasing. And it's very difficult to remove it and very costly. So even in Germany, some of the drinking water sources, they have to introduce a reverse osmosis process because that's the only way to get out PFAS. But that's very costly. So it's very difficult to do that. So what is the proposal? And it is very simple. And that is, it's a uniform proposal. It's from the ski wax, from the Teflon in your pen and whatever. It's whatever is PFAS should be restricted. Otherwise, if we don't have any alternative, there are some exemptions. But as I will show you very soon, we have a lot of alternative, especially in our sector. So what should not be manufactured or placed in the market is everything which have 3 F atoms around the carbon molecule. So fully fluorinated carbon is part of the deal. It's a PFAS. And they should not be placed in the market. That is what it is all about. So the US Army is also concerned, and they want to do a transition. So what they did, they tested their existing system, which is HFC 134A. They fired a bullet on a radiator, which is fully charged, in the HFC system. So the radiator gets punctured, refrigerant is released, okay, it's sad, system is empty, going empty, it will not work anymore. So what happened if you do it with a substitute, which you have in all your cars? So US Army did the same again with that kind of system. Maybe it was. Please, can we go back to see it? Yes, now it's coming. So same system, the radiator again. They shoot the bullet. Hopefully it comes. Why doesn't it work? Please, show it. I'm not continuing if it's not coming. It comes. See, same system, they shoot on it, and this is what happens. And this can happen to your car also, because it has exactly the same fluid. So for US Army, and this is mildly flammable, so it continues mildly to burn. So then the remaining car is also burning, I would promise. So that's a challenge, a risk challenge. So what are the alternatives? We have hydrocarbon, we have ammonia, and we have hydrocarbon. That was the shot. So hydrocarbon we can use for hot water heat pumps. We do that in Japan, we do it in Europe, and we do it for chillers. We have hundreds of thousands of supermarkets using CO2. I will come back to that. And we can do heat pump chillers, and in the fishing industry and food processing, if you have a leak of CO2 in a food process plant, nothing is contaminated. Ammonia is excellent. It is the best working fluid you can get, super energy efficient, and everybody has a sensor. And if these systems are tight, you will love them because they use so less energy and very efficient. And we can do even high temperature heat pump. We can do 95-degree supply. Hydrocarbons, you use it at home, in your fridge, in your chiller. And with new technology on compressors, we were just talking about low charge, we can do even small air conditioning. If you go out for the break, grab a cold water from that small box, it's with R290. It's a hydrocarbon in our lobby out there. So it's for the home appliances and high temperature heat pumps. Even we can do steam with this kind of heat pumps. And if you look to your process industry, on your platforms or on your oil and gas industry, that's what we are using. These are the working fluids to make the gas, to process it, and these assets are valuable. That's why you use them. And they're very safe if you know how to do it. And as you see on the slides to the right, it has been there before. The propane is the odorless safety refrigerant. This is an announcement from the 1922. from the other side of the Atlantic Ocean. So the development of CO2 refrigeration, the revival came in the late 1980s. We saw the first cars, test systems, and what these guys and ladies saw with these cars, it was ice cube in your face. The system was so aggressive, fast in cooling, they were very impressed. That's why they continued. We see the first supermarkets in the close to the 2000s, and Costan and now EPTA, they made the first CO2 commercial units in Italy. Linde did it in Switzerland, and today we have more than 200,000 supermarkets around the world, even in these regions, and we will hear more about that. So in cars, buses, and so on, we use CO2 because it's not flammable, it's very safe, and we can do it super efficient if you know how to do it. So there is no technical restriction or challenge even to operate it here. Knowledge is important, and training to have the right people to do the service. And I will rephrase it later once more, but look, the refrigeration system or the HVAC system is the heart of your asset. Would you go to a guy in the street, can you fix my heart? No, you go to a person who knows what to do. And then you can keep your asset alive, and it will stay very long. So, examples, this is from Jordan, together with Unido and some Jordanese company, we leapfrogged from an R22 system for that supermarket to a CO2 supermarket. They saved a lot of electricity in Jordan, in Amman, a lot of CO2 emissions, no leak, no purchase of R22 annually, and the system never went down since 2018. No food loss. They are super happy. Another one you see close nearby, EPTA will talk more about it. And then a little bit about innovation. This is now, sorry, a bit technical, but we can really develop together these kind of systems applicable even in this part of the world where we have high ambient temperature. And I promise you it will work, and you will be satisfied. The owner will be satisfied. And the advantage is not, don't focus too much on that hot side. CO2 can do a brilliant job on the cold side, and that is where the difference comes. So the starting point for a CO2 system is much different compared to a current HFC system. That's why we can outperform even in warm climates on the annual base, and how to do the integration. So together with you, your engineers, your universities, and so on, I'm happy to share the knowledge, how we can do this together, and I will show you more examples. This is an example from India. So together in India, we did this chiller for a battleship. And the Indian Navy, they came with this white, you know the Navy guys? They were so happy because they can install this because it's so compact. CO2 is much more compact because of the properties. So they can bring this into the elevator, down into the machine room, and fix the old one. If they would have had to replace the original one, they have to cut the hole in the battleship, and that is this much of steel. The cost is horrible, and the strength of the ship afterwards is questionable. So that's why they want to replace it with a CO2 system. And of course, at high seawater temperature, 36, but still it is working good. So it's an option, and they will buy more of them because they can get CO2 everywhere in the world, and they have it even on board. For the fire extinguisher, the fire extinguisher on board is a huge CO2 system. So that's why they have to charge. This is another one, and this is the same, yes. So more than 5,000 hours it has been in operation now to demonstrate, and no issues. Another one is going to the largest chocolate manufacturer in the world, even in India, south part of India, they use this to make chilled water. You see, from 12.7, and on the other side, they make 90-degree water, which is the feed water for the steam. So by integrating this into the process, it's super efficient. So they pay one electricity bill, they get chilled water on this side, and 90-degree hot water on that side. That's business, okay? And high ambient. This is an application also made in India for a smaller warehouse or small capacity, 20 kilowatt, to maintain cold storage for food, as an example. Even at high ambient temperature, 45, 50, this will operate, not a problem. How do we do it in Norway? This is Norwegian law. And the state, the county, or the municipality must adjust procurement procedures, practice. That is by law. Reducing harmful environmental impact. So this is what you also can do. If you, as the owner, say, I don't want that, I want to be sustainable and smart, I want to have a natural working fluid in my asset, then you will get the supplier, I promise you, because they want to deliver a solution to you. But if you're not asking, they will give you something. You should ask for it and tell them, I want to have that, because, as Marcus said, we are soon short on recharging fluids. So in summary, food is super valuable and essential for our mankind. So we need to be safe and reliable on the refrigerants equipment also, not losing food. And safety at work is even more important. We cannot lose these mechanics. We cannot lose or jeopardize our health neither. Nobody should get sick due to refrigerants, even in our assets. That's why the natural refrigerants are really the safe choice. Training together, we can develop this training and do it. Bring these people to us, bring them, we can bring the trainers together here and we help them. And they do it in India. We can bring these people here. It is not a problem. So environmental impact is a major importance, and natural refrigerants, working fluids, will be the choice. It's about awareness. You have to ask for it. Otherwise, it will not happen. Or it will happen later. The focus has to be clean and not green. That will help. So, all vital cooling and heat pump can be made with natural working fluids if you want, if you ask for it. Flammability is not the problem. Look at your gas platforms, process plants. We have the standards. If the standards are followed, we have trained people doing this, and you ask for it, you will get the quality and it is safe. In case you need really something non-flammable, we can do it with CO2. And sometimes a combination is smart. We can use a flammable fluid outside, but what goes into the building is CO2. And this is super efficient. The pumping power will be negligible. That is the way. We have lately made a chicken slaughter in our country. Into the process plant, there is no water circulation. It's only CO2. They're saving so much money on pumping power, and the process is super efficient. I can help you on that. And it must be also mandatory that you request to get all the impacts known from the fluids you are using in the systems, and the byproducts, and the production. Because to date, this is not given by the suppliers of these refrigerants. So an LCA analysis is not possible. On the way here, I wrote a PhD from a colleague in Italy. I'm in the committee. She couldn't do an LCA because she was not able to get the data from the production of the synthetic fluids. It's a shame. So, the PFAS restriction, which everybody is always, it's a challenge. It's not a challenge for our sector. It's good because we can showcase that our sector can help. We can deliver the solutions, and we can help the politicians to achieve, we can help the countries to achieve the goals faster than the lines show us. It's possible. So from now on, we should leave the artificial chapter. The sooner the better, and Europe tells us you can get it from Europe, but also from India, I promise. And the prices will be different. So, new refrigeration and heat pump system must only apply new. We have a lot of old ones which need to be maintained and so on. So this has to be done, and in a safe way, reduce leakage, keep it alive as long as it is possible with the existing fluids and some substitutes. But for new ones, how? That's why I'm asking, can you invest twice in the title? So end users, they will be very happy if they are informed, because nobody wants to own a bad asset, and it turns to be a bad asset very soon if you make the wrong decision in the very near future. So let's develop together the first CO2 supermarket in Saudi Arabia. Why not? We can use it for training our staff and showcase it. We can also develop a CO2-based heat pump chiller for a hotel or whatever. And the Estidama, it will be really low-hanging fruits for that pearls, I will promise you. It's possible. And we can also do it for the training and showcase that innovation is possible, and you don't need to wait until 2030 something. Thanks for listening, and I hope we have time afterwards for questions, and I'm happy to answer many of them. Thank you for having me here.